Reciprocal trig functions. This is where curiosity didn't quite get the cat. In fact, it found something fantastic and new. We know 3 trig functions already. We know sine x, or sine of an angle, and we know that that is the opposite over the hypotenuse. This is just GCSE. We know cos x, does not look like a cos, there we go. That's adjacent over hypotenuse. And we know tan x, which is opposite over adjacent. And I think probably most people will think that's it, but in fact, there are 3 more, and that's what we're going to learn about today. Now, hopefully, by now you all know what reciprocal means. Reciprocal is to put over 1, or in the case of fractions, you all know it's the flip, but reciprocating is to put your function over 1, or your number over 1. So, if we already know what sine x is, then the reciprocal of sine, the reciprocal trig function for sine will be 1 over sine x. And if we have cos, we could look at the reciprocal of cos x, and again for tan. And it turns out these 3, can't count today, these 3 functions are new trig functions for us. So this is cosec x, this is not that, this is sec x, and this is cot x. Now if you ever forget them, Ronnie's got a brilliant trick. Look at the 3rd letter in these new identities. So sine begins with an S, the 3rd letter in cosec is S, so those 2 must match. Cos begins with a C, obviously. 3rd letter in sec is C, so those 2 match. And tan begins with a T, cot. 3rd letter is T. So it's not quick, but it's a nice, easy way of remembering how these pairs match up. So what do these actually represent? Well, if sine x is opposite over hypotenuse, so it's the relationship of the opposite divided by the hypotenuse, it's a ratio, then the reciprocal graph, cosec x, or 1 over sine x, is going to be 1 over the opposite over hypotenuse. Now I know I've done a double fraction and that's a bit horrible, but it serves the point for this. And we know with fractions that when we reciprocate them, we're going to flip them upside down because we're doing 1 over the fraction. So that ends up being 1 divided by opposite over hypotenuse, which is the same as 1 times the hypotenuse over the opposite. So cosec x, the reciprocal graph of sine x, is the relationship between the hypotenuse and the opposite. Still the relationship between the hypotenuse and the opposite, but it's now in reverse, it's been reciprocated. So likewise, sec x, which is the reciprocal of cos, is hypotenuse over adjacent, and cot x is the relationship of the adjacent over the opposite. That last one, cot x, being the relationship of the adjacent, I can't spell adjacent, over the opposite, might make you think about how else we could write cot x. So at the moment we've got cot x equaling 1 over tan x, but we know something about tan x. Tan x is sine x over cos x. We learnt that last year in C2. So what would 1 over tan x be? Well, again, we'll do a double-decker fraction, but okay, we're doing 1 over sine x over cos x, which is 1 divided by sine x over cos x over here, which is 1 times cos x over sine x. So what can we conclude? Well, cot x is cos x over sine x. So if tan x is sine x over cos x, cot x is cos x over sine x. That's quite a useful thing to remember. To look at the graphs, we're actually going to do this in class, but if you want to have a go at this before the lesson, have a think about how sine x, or the graph y equals sine x, behaves in different ranges. So what's happening to sine x as x goes from 0 to 90? And then think what would happen if you took those values and reciprocated them. That will help you draw the graph of cosec x equals y. But we will go over this in class. Okay, so we might need to use these functions to look at values on their graphs by inserting a value of x or theta or whatever it is along the bottom and work out what the y value is. We might need to use them to find values of x. So solving them a bit like your trig equations from C2, and we'll do all of that now, so we'll have a quick discussion about these. If you look at your calculator, you are not going to find a cosec button on it, unless you are very, very lucky, but you are not on most standard calculators, which means we're going to need to rewrite our cosec, our sec and our cot back into sine, cos and tan. Quick reminder then, cosec x, cosec of the angle is 1 over sine of the angle. So the angle stays with the trig function. It doesn't get reciprocated itself, it stays with the trig function. So cosec 1.8 is 1 over sine of 1.8, which we could shove into a calculator if it's in the right function, and mine is not, so that's going to be really helpful for me. If you were to do that in degrees, which I wouldn't recommend you did, you'd get 0.0314, and unfortunately I don't have my normal calculator here, so I have got absolutely no idea how to change it into radians, really helpfully. But you could put that in your calculator, and then, so you could put this into your calculator, hit equals and put 1 over the answer, or you could do it all in one fraction, doesn't matter. But the key thing is the angle has stayed with the trig. So for cot of 0.7, cot is 1 over tan, so we're going to end up with 1 over tan of 0.7, and you could find a numerical value for that. So you do need to be really careful. Even if the angle, this is a fraction, it's not going to reciprocate, because the angle, the x value or theta or whatever it is, stays with the trig function. So this is going to be 1 over tan of 3 pi over 11. That angle isn't going to change. And again, chuck it in your calculator, 1 over the answer, whatever. We can also use our reciprocal trig functions to find values of x. So we've been finding values of y, it's been fairly easy. Finding values of x is just like solving your trig equations from last year, but we've just got these new functions to play with. Again, the angle stays with the trig function, so don't be tempted to try and rearrange things at this stage. We need to get it into sines and coses and tans, because that's all our calculator can show us. So sec x is 1 over cos x, and that's equal to 3. So all I've done is change that left-hand side from sec x to 1 over cos x. I haven't moved the angle or done anything with it, it stays with the trig. Right, now I could rearrange. So I can multiply both sides by cos x, leaving me with 1 equaling 3 cos x. And so then a third is equal to cos x, and then it's exactly like you would do a trig equation from C2. So we'd do cos to the minus 1 of a third, we'd find our values of x's, and then we draw our graph, or we do our circle, whichever one, your unit circle, whichever one you are leaning towards, and find your values of x in your range. So it should be 2, I think. Again, I've got this rubbish calculator, so I can't do that. Oh no, I could. My calculator's in degrees. How useful. Okay, so cos to the minus 1 of 1 divided by 3, that's equal to 70.528. If you're looking on your graph, that's going to be about there, which is 70 away from 0, so we'd want to look at, or 70.5 away from 0, so we'd want to look at 70.5 away from 360 to get our second solution. So 360 minus our answer is 289.5 rounded, with our 70.5 before. And if you're on the car circle, obviously 70 degrees around, reflect it into the other positive, that's 70 back from 360, which gives you your 289.5 again. Okay, so same principle here, just we're dealing with cot instead. So cot is 1 over tan x. I haven't moved the angle, I haven't reciprocated it, stuck with the trig. That's 0.1. I could rearrange so I get tan x equals, so multiply both sides by tan x, and then divide, and I've got my standard C2 trig equation. So tan to the minus 1, I'm not even sure I can do this, 10, oh I can, look at that. X is 84.289, graph asymptotes at 90 and 270, so we're going to 84, it's about there, which means we want to go 84 on from 180, so let's add 180. So my two solutions should be 84.3 and 264.3. And in a cast circle, we've got positives here, negative, positive, negative, 80 straight through. So we've got 80 from 0 and then 80 on from 180, and that gives me back my two solutions, which is good. You can check. You can always check these. Check them just by substituting in your angle. So if you found x equaling 84 what did we say? It was 84.2 to cot x equaling 0.1. 1 over tan x is 0.1. That won't be too difficult. Take your 84.2, substitute it into your x value, and check that 1 over tan of that value gives you something approximately 0.1. It won't be exact because we've rounded this 84.2, but make sure you do your checks. No excuses.